So welcome to Bloodhound. What we're going to do now is we're just going to take a peek behind the door. We're at a very exciting stage of the project where we're starting to get into the real nitty-gritty of the car itself. And let's not forget, this is a 1,000-mile-an-hour car, and this is the year when we're going to take it to South Africa and run it up to about 800 miles an hour and capture the current land speed record, which currently sits at 763.035 approximately, and ultimately we're going to go for 1,000 miles an hour. So let's go and have a look. So this is our workshop. We moved in here approximately about 2 years ago. So we're assembling the car, and apologies for the crashing and banging that's going on behind me. So the car itself fluctuates from being almost looking like a full car through to just looking like a collection of parts, and we're lucky enough today to see almost what is a full car just behind me. The car itself is constructed out of titanium, aluminium, steel and carbon fibre, its main components, if you like. And what we're going to do now is just have a quick look around the car itself. So follow me and come and have a look. So we're talking about that titanium part of the car. So this structure here, these upper panels are all titanium, and they're riveted onto aluminium ribs, and with about 11,500 rivets. And that was done by the team of guys that you can see around us here today. And yes, this is really wood. These are the air brake doors, and what we've done is we've mocked them out of plywood, one of my favourite materials when I was being a builder, to construct stuff out of. And this is just sort of so we can test the hinges that the air brake doors work on, so while the actual air brake doors are being manufactured. And those air brake doors are going to be carbon fibre, and they'll have lots of holes in them, and that's to allow air to pass through them and stabilise the airflow that is going to exist behind them. These will be the fastest air brake doors that we've ever made. We have had air brake doors on aeroplanes, but at this altitude and this thickness of air, this is unique. So another first, if you like, for the project, and there's plenty of those. Moving along the car, so if we focus down here in this empty space down here, this will hold the V8 engine. So we have 3 engines on the car. We have a EJ200 out of a Eurofighter Typhoon, so a jet engine, suck, squeeze, bang, blow, needs oxygen, so it has an air intake, sucks the air in, goes through the engine, comes out the back as thrust. We have a rocket, which we have to carry our own oxidizer for that rocket, so we have a ton of that. That's HTP, it's a liquid oxidizer, and we need an engine to run a pump to pump that into the rocket in about 17 seconds. So we shift 1,000 litres of HTP in 17 seconds, and that goes through the rocket, turns into high temperature steam and oxygen, and ignites and then burns the rubber that's inside the rocket. So it's called a hybrid rocket, and that's where the engine sits, and just behind that sits the fuel tanks for the jet engine. So we carry 1,000 litres of HTP and 500 litres of Avo fuel. So we burn 1,500 litres of fuel in approximately 55 seconds. So moving down to the front of the car, what we have here is the carbon fibre structure. So the car kind of splits into 2 halves. The rear end is an aerospace construction, and the front end of the car is motorsport, and that very much reflects the design disciplines of the 30 or so engineers we have up in the design office, and also the team who are actually going to put the car together. So those skill sets are aerospace and motorsport. So this is Andy's office. So this is where Andy will sit in the car. This was where he'll control the car from. And lots of people say to me, well, do you need to have a driver? Well, let's face it, that's where the drama comes from. A remote control car isn't going to excite anybody, and we have a duty to excite the next generation, and so that's why Andy has to sit in the car. So if we go to the other side of the workshop, just while we're passing, if we take a quick glimpse over here, this is one of the supercats. So not only do we have to have the fastest car in the world, we also have to have the fastest fire engines as well. So Jaguar are supplying us with 3 what we call rapid response vehicles. So that's an XE, an XJ and an XF, and they will carry the firefighting equipment that will be the first response should there be any kind of accident on the desert. Second response is this vehicle behind me. It's a Supercat. They're made down in Devon. and they've been kitted out by Angloco to actually carry all the firefighting equipment and extrication stuff that we might need on the pan itself. So we have 2 of these. The second one is being manufactured as we speak. So this side of the workshop has just recently been kitted out to become part of the manufacturing side of things, and we've divided up into 4 separate bays, the first of which contains that HTP tank, and the one at the end has got the tail fin fixture. So we need to build, again, the biggest tail fin that's ever been built to run at this altitude. So it's obviously bigger aircraft that have tail fins on, but in terms of going at this speed, at this altitude, this is the biggest tail fin that's ever been produced. So lots and lots of firsts with this project. We've got the biggest desert, it's had the biggest land clearance, 24 million square meters, where we picked up every single stone any bigger than 10 millimeters in diameter. 315 people have been doing that for the last 3 years, and that's equivalent to the dual carriageway running from Bristol to Moscow. So quite an epic task in itself. What we have here is the EJ200, the Eurofighter engine. So these are normally found, there's 2 of these found in the Eurofighter. This engine is actually produced up in Filton. So they manufacture this engine. It was designed as a consortium of which Rolls-Royce is one of the major partners in that. So another fantastic connection with Bristol through this engine and through Rolls-Royce, who have been a fantastic supporter of the project for many, many years, helping us with the design of the air intake, the design of the wheel, and fairly recently they spanned that wheel up to full speed. So not only are we building the fastest car, but we also have to have the fastest wheels, obviously, to go with it. So these wheels rotate at 10,500 RPM, generating 50,000 G at the rims, and will be the fastest wheel man has ever made and put onto a vehicle that's been driven, which is quite a claim to fame for the company who's manufacturing those, which is a company up in Glasgow. So very much a homegrown project in its entirety. I mean, we do have some sponsors from overseas, Rolex being one of them, but obviously, you know, this is a British project, and this is why it carries the Union flag on the back of the car.